In this video, we will look at the component of vector u along vector v. So the component of vector u along vector v, or we can say it as the component of vector u in the direction of vector v. So from the along, we change to in the direction of vector v is given as this formula, which is the component of vector u along vector v is the dot product of vector u and vector v divided by the magnitude of vector v. Let's look at the exercise. So you can do, first we look at this example. So you can see that given vector a and vector v, so find the vector component of vector a along vector v. So the vector component of vector a along vector v is, this is the formula. First, we need to find the dot product. Then we divide by the magnitude of b. So if we look at this exercise 3, so given that vector u is I plus 3j minus 2k and vector v is 2i minus 4j plus k. Later, we will change to the coordinate form. And then the question is, find the vector component of u along v. So first, what we do is, we try to change the vector into the coordinate form, which is vector u is 1, comma, 3, and negative 2. Whereas the vector v is 2, negative 4, and 1. So in order to find the vector component, so the vector component of u along v. So the formula will be the dot product of u, vector u and vector v divided by the magnitude of vector v. So the vector, the magnitude of for the second vector. So we can find it separately. After that, we substitute into this formula. For example, for this one. So first, I try to find the dot product of vector u and vector v. So here, the vector u is 1, 3, and negative 2. Whereas the vector v is 2, negative 4, and 1. So the dot product will be 1 times 2 plus 3 times negative 4 plus negative 2 times 1. So here we have 2 minus 14 minus 2. So here we have negative 14. Here is our dot product. Sorry, for this one, sorry, 4 times 3 is negative 12. Sorry, this part. So again, for this part, 1 times 2 is 2. 3 times 4 is negative 12 minus 2. So here we have negative 12. So here we have this part, we have negative 12. So this is the output for the dot product. Next, we try to find the magnitude of vector v. So the magnitude will be square root of vector v is 2 squared plus negative 4 squared plus 1 squared. So from here, square root, you have 2 squared is 4 plus 16 plus 1. So here we have square root of 21. Next, we just substitute in this formula. Now we already have all the value, so we can substitute into this formula. The dot product is negative 12 over the magnitude is square root of 21. So since you have this value, or we can, if you want to simplify, what we can do is we can try to multiply by square root of 21 for the denominator and the numerator. If you want to proceed for this part, you should have this part is negative 12 square root of 21 divided by 21. So because square root of 21 times square root of 21 is 21. So if here I try to simplify, I should have negative 4 square root of 21 over 7. Why? Because this part, let's say, here we can simplify by divide by 3. So divide by 3 is 4. This one 21 divided by 3 is 7. So we have negative 4 square root of 21 over 7. So this is the answer for exercise 3.